Hey guys, it's Mrs. Freeman, and this is lesson 5.3. We're going to talk about approximating square roots. So kind of putting what we learned about square roots together with what we've learned about the real number system. Go ahead and label your notes page for this, and then I want you to do this warm-up. Use the Pythagorean theorem, which is a squared plus b squared equals c squared, to find the hypotenuse of a right triangle with the given leg length. So remember, our hypotenuse is always c. That's a funky arrow, but it's always c. So what they're giving you in each of these is a and b, and you want to find c. So go ahead and pause this video while you do that. Okay, for number 1, you should have done 30 squared plus 40 squared equals c squared, and when you added these together, you would have got 2,500, and that's equal to c squared, but we don't want c squared, we want c. That's our hypotenuse, so I have to square root both sides to get c by itself. The square root of 2,500 is 50. Okay, this one came out evenly. Remember what we talked about in class. We said if a square root is not a perfect square, that means it's an irrational number. This one was a perfect square. I got 50. No decimal, no fraction, just 50. And 50, of course, would be a natural number. That's a counting number. I could count to 50 if I wanted to. Okay, so let's try number 2. You should have done 10 squared plus 24 squared equals c squared. And when you added those together, you would have got 676 is equal to c squared. So to get c, we would take the square root of both sides. And the square root of 676 is 26. So again, this one was a perfect square, so it is a rational number, and it's actually, even more than that, a natural number because it's a counting number. Okay, for number 3, I'm going to write over here really small. We've got 16 squared plus 30 squared equals c squared. 16 squared plus 30 squared, if you added those together, you would have got 1,156. But that's c squared, so we would take the square root of that. And this time, I again got a natural number. So all 3 of these so far have been natural numbers, so they've all been rational. Number 4, we'll do over here. This is kind of all over the place. 9 squared plus 40 squared equals c squared. When you do 9 squared plus 40 squared, I think I remember this one from when we did the Pythagorean theorem a whole bunch. It's 1,681, and that's c squared. So the square root of that is just 41. Again, this is a counting number. I could count to that if I wanted to, so it is rational. Okay, number 5. 54 squared plus 72 squared equals c squared. When I square those and add them together, I get 8,100. And that's c squared, so the square root of 8,100, square root of 81 is 9, so the square root of 8,100 is going to be 90. Okay, we got one more here, and we should have done 2.5 squared plus 6 squared equals c squared. And that would be 42.25. So to get c, I would take the square root of that. And that is 6.5. Okay, So this one, I wouldn't necessarily call it a perfect square because I did get a decimal, but I did not get a big long decimal. So that's the difference here. So this would be a rational number because 6.5 would be a rational number because it's a terminating decimal. Now, let's talk about the Pythagorean theorem. Maybe you're going to have a question in your homework, and it's going to be exactly like what we're working on here, but it's going to look like this. And it's going to say this side of the rectangle measures 6, and this side of the rectangle measures 9. Doesn't really matter what the numbers are. And it says find the length of the diagonal. So that's what we're doing here. We'd do 6 squared plus 9 squared equals c squared because that'd be our c. 6 squared plus 9 squared is 117. This is not a perfect square. So when I take the square root of that, I'm going to get a big ugly decimal that is about 10.8. Okay? But your assignment is going to ask you to do two things. It's going to ask you to round to the nearest tenth, and it's going to ask you to round to the nearest integer. So the nearest tenth is what I've done here. Baker, quit. Play with something else. But the nearest integer, would just be 11, right? Because my integers are 0, I've got my negatives, and I've got my positives, but there's no decimals. Sorry, had to shut my dog out. A rational number, this is what we've been talking about. This little diagram down here looks a lot like the foldable that you made and like the notes that we took in class. A rational number is a number that can be written as a fraction. That's what we've talked about. An irrational number is the exact opposite of that. It cannot be written as a fraction. Okay? Rational numbers and irrational numbers together form the set of real numbers. So all of these are real numbers. But remember that my irrational were the non-terminating, which means they don't stop, non-repeating decimals. So they don't repeat either. And real numbers were the exact opposite of that. So that means they do terminate or they do repeat. Okay, let's classify these numbers. That's what we've actually been working on. First, I have the square root of 12. Now, I know that if a number is not a perfect square, or if it doesn't come out pretty, then it's going to be an irrational number. And if I take the square root of 12, my calculator says 3.464101615. Non-repeating, non-terminating. So this would go into the irrational numbers subset. Why? Because it is a non-repeating, non-terminating decimal. And it cannot be written as a fraction. That was our definition of irrational. Okay, and then I have negative 0.25 repeating. That repeating right there tells me that this is rational. Why? Because it's repeating. And I know that I can write repeating decimals as a fraction. All I do is put them over 9. So this would be 25 over 99. However many numbers there are, that's how many 9s you use. But I can write that as a fraction. Okay? If you type 25 divided by 99 in your calculator, you're going to get 0.25, 0.25, 0.25, 0.25 over and over and over and over. All right, I have the negative square root of 9. If I type that into my calculator, I get negative 3. And looking back here, our negative numbers come in our integer spot. So it's a rational number. Well, I don't know where my writing went on B. But it's also an integer. Okay? Why? Because it's a negative whole number. I'm going to write this back, and it's probably going to appear after I write it back. Okay, 72 over 4. First of all, I know that's rational. Why? Because it's written as a fraction, and the literal definition of rational number is, can it be written as a fraction, basically. Okay, but I want to know if I can subset that even further, and if I do simplify that fraction into the calculator, I get 18. 18 is a counting number, okay? So it is natural, but it is also everything above natural, so it's also a whole number. It's also an integer, and it is, of course, rational. Why? Because it's a fraction, and because it simplifies to 18. Pi, this one's easy peasy every time, irrational. Why? Because it's a non-repeating, non-terminating decimal, okay? Pi is irrational. Always. Okay, example 2 says estimate the square root of 71 to the nearest integer and the nearest tenth. Okay, this is what I was talking about earlier. So if I type in the square root of 71 in my calculator, I get 8.426149773, and then the calculator screen ends, but we know because this is irrational, it's never going to end. To the nearest integer means on the number line with my negatives going this way, but I don't really care about the negatives, I just care about the positives. What number or what two numbers would this decimal fall between? Well, on my number line, it's going to fall between 8 and 9. And it wants to know which one of these is it closer to. Well, 8.5 would be right here in the middle, right? But this is 8.4, so that means it's going to be over on this side of 8.5, so that means it's going to be closer to 8. So the nearest integer would be 8. The nearest tenth we know is just this first decimal place, so it's going to be 8 point something. I always use this decimal or this number right here, but I look at the number after it, which is this 2, and if it's 5 or bigger, then my number has to go up 1. It is not, so my number stays 8.4. Okay, so those aren't too bad. There is one thing that I want to tell you about. Some of the questions are going to say the exact same thing, but it's going to say the cubed root of some number. Okay, this is something that you're not super familiar with. We don't use it very often, but just like squared and square root are opposites, cubed and cubed root are opposites. This is a button on the calculator just like square root. If you look at your calculator, this button is what we've been using. It's the square root. Okay, but above that, in green or in yellow, depending on what your calculator looks like, there is a button that looks like this, and it has a little X out in front. That means that I can take any other root that I want. So if I want the third root, what I'm going to do is type a 3 into my calculator. Then I'm going to hit this button. Remember, if yours is above the button in green or yellow, you've got to hit second first or shift, depending on your calculator. Then, whatever number you want the third root of. In this case, 71. And you should get 4.140817749. Okay, so make sure you can do that on your calculator. The Big Ideas calculator will do it as well. It looks like this. Okay, do not use this button. That is not the same thing. If you type 3 and then this button, that says 3 times the square root of this. That is not the same thing. Okay, you've got to use the one with an X in front of it. So if I were to round this right here to the nearest integer and the nearest tenth, right, the nearest integer would just be 4, because 4.1 would be between 4 and 5, but much closer to 4. And then the nearest tenth would be 4.1, because this number is not 5 or bigger, so my 1 stays 1. Okay, then I've got which is greater, the square root of 5 or 2 2/3. So anytime I am comparing two things like this, what I'm going to do is turn them both into decimals. So the square root of 5 is 2.236067 blah, 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 blah. And then I've got 2 2/3, and if I want to turn that into a decimal, I just use the button on my calculator that does that for me. And it is 2.66666, repeating. Your calculator might say 7 at the end, but that's because it's rounding up. But this is repeating forever and ever and ever. Remember, I told you that if we have a repeating decimal, we just write that number over 9. So this right here is a 6 repeating, so it'd be 6 over 9, which reduces to 2/3. So that's why this right here is repeating. Okay, but which one of these is bigger, 2.2 or 2.6? Obviously, 6 is bigger than 2, so 2 2/3 would be bigger. Okay, and lastly, we've got the radius of a circle with area A is approximately the square root of A over 3. The area of a circular mouse pad is 51 square inches. Estimate its radius to the nearest integer. So it tells me the radius is equal to this right here. Okay, and then it gives me the area. It gives me A. So it tells me that A is 51. So all I have to do to solve this is find the square root of 51 over 3. And when you type that into your calculator, you should get 4.123105 blah, 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 depending on where your calculator ends. But the question is asking me to round that to the nearest integer. And remember, for integer, we just look at a number line. 1, 2, 3, 4, 5. This 4.1 would come between 4 and 5. It is definitely going to be much closer to 4 because it is 4.1. So the nearest integer would be 4, and we're talking about inches.